بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. النهاردة إن شاء الله هنستمر في درس البكرات البسيطة. طبعا نظرا لأهمية البكرات البسيطة لاستخدامها في المجتمع، فبنستخدم الدرس الثاني على البكرات البسيطة. وقلنا الهدف من دراسة الدرس البكرات البسيطة إن الكل يعلم إن إحنا بنحاول نبسط اما تيجي تحرك جسم الى جسم اخر، فبتستخدم البكرات البسيطه لتخفيف الحركه. Welcome my dear student in our math program for second 3. Today we are taking new lesson in dynamic. Follow the simple Pauli. Dear student, now we are taking the first example in smooth Pauli. Two bodies of mass 105 gram and 70 gram are connected as the two ends of a light string passing over smooth Pauli to be hanging vertically. Remember, dear student, we have two bodies of mass 105 gram and 70 gram are connected the two ends of a light string passing over smooth Pauli to be hanging vertically. If the system started motion from the rest, remember, if the system starting motion from the rest, then initial velocity equals 0. When the two bodies in the same horizontal level, find acceleration of motion, and if the first body is impacted by the ground after covering distance of 50 centimeter, find the total time from starting motion until it came to rest instantly. Solution. Look at the first equation is 105g minus t equals 105a. This is the first equation of the first body. We know that the first equation of motion ma equals mg minus t. In the first body, its weight 105. Then 105g minus t equals 105a. The second motion equation, t negative 70g equal 70a. Remember the motion with vertically upward with direction of the greatest body 105. By adding the two equations to find the value of acceleration, then 35 times 980 equals 175a. What is the value of a? The value of a equals 35 times 980 over 175. Then acceleration is 196 centimeter per second square. If we have the second Newton law is S represents the distance equals ut plus half at square. Then by substitution about S equal 50, initial velocity 0 and E is 196 to find the value of t. Then t squared equals 100 over 196, find the value of t, 1 equals square root over 100 over 106 equal 5 over 7 seconds. This is t1. By using the first law to find the value of the velocity, v equals u plus at. At, a is 196, t equal 5 over 7, initial velocity equals 0. Why? Because the velocity from the starting motion, initial velocity equals 0, then v equal 140 centimeter per second. Then respect to second body, v equal u plus gt. Then 0 equals 140. This 140 is velocity of the system when v equals 0 plus negative 980, this direction of acceleration, times t2, then t2 equals 1/7 second. After that, we find the t, sum of the two time t of the system is 5/7 from second plus 1/7 equals 6/7 second. Another example. If we have two bodies of mass m and m plus 56g are attached at two ends of flight string passing over a small smooth Pauli. The two parts of string are vertically. The system is left to move from rest when the two bodies in the same horizontal level. After 1 second from starting motion, the vertical distance between them was 98 centimeter. What is the required? Find the acceleration of motion and m and the pressure of the Pauli. Look at the solution. Look at, we have two bodies, m plus 56 and m. The first equation of motion, m plus 56g minus t equals m plus 56a. The second equation, t minus mg equals ma. By adding, then find the value or the relation between g and a. mg plus 56g minus mg equals bracket contains 2m plus 56 times a. Look at mg plus negative mg equals 0, then we find the value of acceleration by left hand side equation is 56 times 980, right hand side is 2m plus 56 multiply a. Then s equals 92/2 equal 49 centimeter. Remember, s equals ut plus half at square, the distance divided by 2. Why? Because s2 divided 2, then by substitution s equals 49 and initial velocity equals 0. To find, add the value of t acceleration, then by substitution 56 multiply 980 equals 2m plus 56 times 998 divided by 98. Then to find the value of m equals 252 mg. Since t equals m plus g plus a, we find the value of m and g and a by substitution to find the value of t. Then t equals what? T equals 271,656 or 200 divisible by 277 to calculate the convert from dyne to gram to watt, then divided by 1000, 271.2. Since pressure equals 2T, by substitution 2m multiply 277.2, then by substitution about m, then B equals 554.4 gram watt. Another example. Two bodies of mass 300 gram and 200 gram are tied to the end of a light string passing over smooth poly, and they are in the same horizontal level. The system is left to move from rest, and after 1 second, the string has broken. String, remember, has broken or cut. Calculate the distance between the two bodies after another second from the moment of breaking the string. Solution. Look at your right equation of motion. The first is, we have two bodies. The first body, its mass 300. The second body, its mass 200. Then we form the equation of motion of the first is 300 g minus t equals 300 e. Then t minus 200 g equals 200 e, the second equation of the second body. By adding, then 100 g equals 500 e. Then by substitution about g equals 980, find the value of a. 100 times 180 over 500, then acceleration is 196 centimeter per second square. After that, calculate the velocity and the distance at time equals 1 second. Remember, dear student, the first Newton law is V equals U plus AT. By substitution, initial velocity equals 0, acceleration 196, and from the given t equals 1. Then V equals 196 centimeter per second. Remember, the velocity 196 centimeter per second, but acceleration is 196 centimeter per second square. The same value, but not same unit. The same unit of velocity and initial and final velocity, but the velocity it's unit centimeter per second. Also, S equals second Newton law is S equals ut plus half at square, or v naught t plus half at square. By substitution, about initial velocity 0, t equals 1, a is 196, and find the value of S1 equals 998 centimeter. Then, with respect to mass of the second, 300 gm, then after cutting, the string moves downward with initial velocity is 196 centimeter per second, and with acceleration of gravity, g is 980 centimeter per second. After we substitution of the second Newton law, S equals v naught t or ut plus half at squared, then we find the value of S, or the second distance, 996 times 1 plus half times 980 times 1 square. Find the value of S2, then 190 plus 996 plus 490 is 686 centimeter. Then we find the sum of the distance, the mass 300, descending a distance, sum of two distance, the first distance plus second distance, S1 686 86, S2 98, then the mass 300 a distance is 784 centimeter. With respect to the two mass, 200 gm2 come to the rest. Then what is the given? V equals 0, G equals negative 980, tradition. Initial velocity 196, pi, substitution about the first, then V equal U or initial velocity plus GT, then find the value of T, T equals 196 over 980 equals 1 over 5 from the second. After that, we substitution in the second row to find the S2. S2 or the distance equals initial velocity times T plus half GT square. After that, substitution about U and T GT to find the value of S. S equals 180 times 105 equals 58.5. Dear student, now we are translate to another example. This example is very important. The first type of smooth Pauli in the horizontal level. But if we have plane and the body inclined, this plane inclines the horizontal by angle, okay? And we have the body moving in this plane is inclined by horizontal plane and the other end has Pauli. This example is very important. Remember, dear student, this example we have two levels, the inclined plane and vertical plane. We have two equations and form third equations. After that, we have initial velocity and final velocity and the distance between the two bodies. Dear student, look at important example. Body of mass 140 gram is placed on rough plane inclined to horizontal at an angle whose sine is 4 over 5. The body is tied to one end of a light string which pass over smooth Pauli. Small Pauli fixed at the top. Remember, the body is tied to one end of a light string which pass over small Pauli. This smooth Pauli fixed at the top. The other end of the string carries a body of mass 280 gram. If the coefficient of friction between the body and the plane is third, and the system start motion from rest for 3 over 2 seconds. Then the string is cut. Find the time taken by the body placed on the plane from the beginning of the motion until it comes to rest. Remember, the required is the time taken by the body placed on the plane from the beginning from motion until it comes to rest. Look at the solution. Dear student, rough plane. What do you mean of rough plane? Excellent student. We have friction force. The T is force has friction force MR. And look at the opposite figure, dear student. The first body 280. 280, its equation is 280 A equals 280 g minus t. The second body is 140. 140 is its weight represent perpendicular to the horizontal. We resolve 140 g with two vertical line, x-axis and y-axis. The first vertical downward 140 g cosine theta. Why? Because the plane or rough plane inclined with horizontal plane with theta. Look at 140 is resolve 140 g cosine theta and it's perpendicular 140 g sine theta in the line of inclined plane or horizontal, the plane parallel to the inclined plane. The motion start to remove 280. Look at the first motion vertically. R equals 140 g cosine theta. This is number 1. By substitution about cosine theta equals 3 over 5 to find the value of R. Then R equal 140 times 3 over 5 g equals 84 g. After that, look at if we have sine theta 4 over 5, cosine theta 3 over 5. Then the second equations or by substitution about 280 g minus t equals 280 a. After that, the second equation of motion t minus mu r. Mu r, what is the mu? Coefficient of the friction. Mu r minus 140 g times cosine theta 4 over 5 equals 140 a. Remember, dear student, we have two equations of motion. The first is 280 g minus t equal 280 a. This is number 1. Number 2, t minus mu r minus 140 g times 4 over 5 equals 140 a. By adding, we form equation, third equation is 280 g minus mu r minus 112 g equals 420 a. By substitution, about mu equals third and the value of r, then 280 g minus third times 84 g minus 112 g equals 420 a. This equation to find the value of acceleration a. By substitution about g, then answer is 980 times bracket contains 280 minus 28 minus 112 equal 428. Then at 180 multiply 140 equals 428. To find the value of acceleration, then A equals 980 over 3 centimeter per second square. After that, we know that the first Newton law is V equal U plus AT. By substitution about initial velocity equals 0 and A is 980 over 3 and T is 1.5, then V equals 490 centimeter per second. Since, dear student, T minus mu r minus 140 g sine theta equals 140 A dash. To find the value of A dash, the second acceleration 140 A dash equals 180 multiply bracket negative 28 minus 112. Then the acceleration becomes negative 980 centimeter per second square. After that, since v equal u plus at, by substitution v equals 0 and acceleration 180 with negative. To find the value of t, then t equal half second. Then t equals time, total time b equals t1 plus t2. The first t1 equals 3/2 and t2 half second, then t equals 2 second. By adding 3/2 plus 1/2 equals 4/2 equals 2 second. Now we are translate to another example. Body of mass 100 gram is placed on a plane inclined to horizontal at angle of measure 30 degrees. It's connected by a light string passing over small pole at the top of plane to be tied at each other into a body of mass 150 gram. If the coefficient of friction force is 1/√3, find the time which passed before the first body moves the distance 200 meters on the plane and obtain its speed. Then solution. Look at, dear student, we have two bodies. One is put on plane inclined by 30 degrees horizontal plane, and the second 150 gram. Then we form the first equation, r equals 100 g cosine 30. By substitution, cosine 30 equals √3/2. Then r equals 50√3 g. The second motion of the second body is 150 g minus t equals 150 a. After that, we have third equations, t minus mu r minus 100 g sine theta equals 100 a. By substitution and add two equations, then 150 g minus mu r minus 50 g equals 250 a. We find the coefficient. We have coefficient mu and r and g to find the value of acceleration a. By substitution, then 150 g minus 1/√3 multiply 50√3 g minus 50 g equals 250 a. Then find the value of a by substitution about g 980. Then acceleration is 196 centimeter per second square. After that, we use the second law of Newton, S equals initial velocity u t or v naught t plus half at square. Distance is 200, initial velocity 0, acceleration 196. To find the value of t, then t square equals 200/98. After that, we find the value of t by using square root equals 10/7 second. Then v square equal v naught square plus 2as. Remember, dear student, v square equals by substitution u square initial velocity equals 0 and 2as, s is 200, acceleration 196, find the velocity v square. After that, we find the value of v by using square root. Answer is v equals 280 centimeter per second. Dear student, by the end of the lesson, we know more types of simple Pauli. Simple Pauli in horizontal plane and plane inclined to horizontal plane. This lesson is very important lesson. I am very happy to spend such time with you. Goodbye.